on to the really interesting stuff now, okay? I've talked about how, you know, what to consider. I've talked about, you know, the type of specification and the details of it and everything else like that. Now we're on to planning a lesson. Now I've got highlighted here the learning objectives that I would consider when I am introducing enzymes to a class. And this is to a class of year 10s, okay? And I really need them to be able to sort of get to this particular stage, but they need to have the basics, the defining of enzymes, the defining of what a catalyst is, and sort of describing how they sort of interact, okay? And in here, okay, we're not going to be able to cover all of this in one lesson, okay, or one session of a lesson. So I'm going to have to sort of pick certain aspects, okay? Now, in this particular situation, I expect, okay, all my students to be able to state the definition of an enzyme and a catalyst. I expect them to be able to sort of draw and think about what the enzyme structure is and why it's so specific to a substrate. And I expect them to be able to sort of identify on a graph, okay, the optimum pH or the optimum temperature on a graph, an enzyme activity graph. So you see here we've got a mixture of just sort of, you know, like reciting information as well as thinking about descriptions. It's literacy and then also numeracy. Here for the stretch and the challenge, okay, when they're looking at the graph, I want them to be able to think about what part of that graph is the enzyme activity increasing, when does it stop, and what happens after that. So, you know, we've got to be able to sort of, you know, get them to think about, you know, the different factors that affects enzyme activity as well as what's happening during that enzyme activity. So we've got a lot of literacy as well as numeracy going on here. So this is, not all students are going to be able to do that, but here at Nlcs, we expect them to be able to do all of that by the end of the lesson, okay? Now, this is in our lesson plan. I've got to list all the teaching resources that I'm going to use. I then have to think about the differentiation strategies, okay, and it's not just so that those that are more, you know, less able. I've actually got to make sure that the more able are challenged, okay, and so I've got to put in quite a few things that I've got to think about there for them. Homework, of course, is essential. Like I said before, this is what has to happen for this particular course, and so this is an example of what I would think about covering in my particular lesson. And, you know, I'm not going to read everything out there, but you can see that there's quite a lot of, you know, different sort of resources that I've thought of, not just sort of things for them to write on or to think about. I've got my PowerPoint, I've got whiteboards, okay, mini whiteboards, so that there's a bit of activity going on and lots of, you know, like rough thinking, so to speak. We call it rough thinking, but it means preliminary thinking. That's what rough thinking means. Preliminary thinking to make sure that they start to feel confident with the information. A mind map for literacy, and this is to help, you know, students who've got potentially English language challenges, okay, just to help them be able to access the information at pace, and graphs for numeracy, okay, and again, give them a piece of homework so that they can actually practice what they've learnt in the lesson at home. Now, this is, what I'm going to do is I'm going to show you, I'm not going to go through it bit by bit. In fact, you'll be able to look at that later and go through it in detail later, and you'll be able to sort of, you should be able to, okay, line up all these different points here with my PowerPoint that I'm going to show you in a minute. And I'm going to talk through more in the PowerPoint than I am going to talk about what's here. But can I just point out just a few things before we go off into the PowerPoint, or indeed any further? Here, lessons in our school here are 40 minutes long. That's not enough time, okay, to do any sort of practical work or cover quite a lot of information. So we generally have 2 lessons at once. So that's a double lesson, and that means we have 80 minutes in that session. And so I've planned for a lesson here, which is sort of like, to me, a normal lesson, an 80-minute lesson, okay? And so here you will see all of this adds up to, the time taken will add up to 80 minutes. Okay, now the pace of lessons are generally quite quick, okay? No student should be sitting down and thinking, you know, what am I going to have for lunch, or what's happening outside the window. They will be really quite busy, okay? And so they're all working and discussing things constantly. Now, I've got sections. I've put it into a starter section, a self-assessment section, okay? And I've also got new knowledge section, okay, where students are going to hopefully find something that is new to them in that lesson. And then I've got the practice of apply of that new knowledge, and then finishing up all the plenary. Now, you will find, okay, in international schools that there are quite a few of us that have trained in the UK, okay, and some of those particular structures that we put to lesson plans will involve sort of words like words that we've been encouraged to use, okay, within our lesson plans. And some of those words will be like a starter. Now, the whole idea of a starter, it could be called anything else, okay, but generally the starter is generally what, you know, we use in terms of describing, making sure that we've got something up on the board so our students can actually see it and start thinking about what are we actually going to learn today. So you're getting them thinking, and once you get them through that door, you want them to be in the biology zone, okay. And then self-assessment, that's something that you want them to find out how much they know, okay, before you start teaching. Okay, don't expect your students to know a lot about your topic, but also don't expect them to know nothing. They will know something, and you need to be able to work that out before you start teaching them new information. So you can adapt your lesson while you are there in that classroom. So even though I've got that all stated quite nicely like that, you've got to be prepared to sort of adapt this to your students, because they could be really quite interested, or they could be not so interested, and they need a bit more time in different sections, okay? Now, onto the new knowledge. I've got there lots of, I get them to reflect an awful lot, use a lot of self-assessment. I get them to try and do lots of physical activities and things like that. And then I also get them to sort of talk to each other an awful lot about what's going on around them. But you can have too much talking and you can have not enough talking. So again, when you are there in the classroom, you have to actually decide, was that too much for my class? Was that not too much? How are they responding? Are they sick of talking? Let's give them something else to, let's go on to the next section, okay? So you're always thinking. Now, next bit, practice and application of the new knowledge. This is essential. Whatever happens, you need to make sure that you cover this in your lesson, because they have to be able to sort of apply, okay, what you've just gone through to different scenarios. Now, some students will be able to do it to the whatever material you put in front of them. Some students will actually immediately start thinking, wow, how can I apply that to different real life scenarios. They might start thinking about something in medicine. They might start thinking about something that applies to their family. So be prepared, allow them to have this opportunity. And then finishing up, if you run out of time at any stage in the lesson, you always need to make sure, and this is something that's pressed upon all of us here who are teaching in an international school, is that you must finish up with a plenary, an opportunity for the students to review what they've learnt in that lesson. And this is a really important part of cognitive science as well. So it could be quiz questions, or it could be little statements, reflective statements. And I've chosen for them to review their mind maps, and I've chosen them to add more information because this is an introductory lesson, okay? So let's get on with the actual lesson, okay? Now, it'd be really good if you could actually see how the students interact with this particular subject, because there's activity going on in this lesson as well, okay? So my starter is this one, which is the odd one out. It's really simple, it's really straightforward. Students will look at that. These are year 10 students. Now, some of my students will actually start to recognise some of these things, and they'll be able to recognise which one's which, okay? They'll know that that's an enzyme or a molecule or something, but they will not know which one's the odd one out. And this is a really good one because I can get them talking about it. And that's the odd one out because that's basically starch. All these others, even though that's a you know, like a ball and stick sort of diagram, these are all amylase, okay? That's found in the salivary gland. And so you can have conversations about that. You know, is that really in my saliva? Yes, it is, okay? That's what's in your saliva. So, and then I want them then, when they're sort of hooked, so to speak, I want them to write down as many things as they possibly can about enzymes. And they've got to be able to do it from their own thinking, not someone else's, not from a book, not from anywhere else. It's got to be what they can recall. And even if they can only do 1 square or 2 squares, that does not matter. That's our starting point. Okay, so this is where you start to be flexible as a teacher, and you're fluid, okay, in realizing how much your students know or they don't know. This is what I want my students to know. I've got to share that information with them. Now, some schools like that, some schools don't. Here at NLCS, we don't, this is part of our conversations. We don't necessarily put this up on the whiteboard. I've put it here in this presentation so you can see what I'm thinking about, but I won't necessarily put this up on the board. I want to get into the lesson, and I really want my students to really fly, okay? So I expect them to know these particular things at the end of the lesson, but they may not know it at the beginning, okay? Now, again, learning objectives, okay? Those sort of things. Now, I want them, okay, to think about what is an enzyme. And so back here, okay, we've got the definition. So before we start thinking about what is a definition, I want them to write down what is a definition. What do they know as the definition of catalyst and enzyme? And so they'll write it down. They won't know. Some of our students won't even want to give an answer, but you've got to encourage them to write down something. And then I want them to check it against this PowerPoint, okay, what is there? And then I want them to check it against what's here in the specification. And this is the definition they've got to know. So when they see that, they can get that down in their books, and they know that they're starting off at a good spot. Okay. Then underneath, like I said, write your definition down, check it against the learning objectives. But I love our students using different colour pens to make changes to their definitions so that they've got their initial thinking and then they've got their progressive thinking. So it's scaffolded, and they can see it's scaffolded. Okay, so they could start in blue pen, and then they can do this in pink or green or whatever. Okay. Then here, I'm going to ask them to add no more than 2 points from this slide to their mind map. Too many students think they can just sort of, copy things down all the time. I don't want them to copy things down. That's not thinking. I want them to decide on what they know already and what they need to know. So they've got to do that. Now, 2 things. It shouldn't take them long, probably, 3 minutes, maybe 4, and then you go on to the next slide. Here's some more information. Again, you've still got your enzymes here and they can see it. But now this particular slide makes them think about specificity, yeah? Okay, and how the substrate fits into that little particular action, like the active site just there. And so again, 2 things only to add to their mind map. And then I want them to think about what happens at the active site, because we will have already looked at that, okay, here. That would have been part of your conversation with your students. And it could be one-on-one conversation, it could be 2 or 3 people listening while they're trying to work out what they're doing here. So they can understand that there is actually a specific site. And so at this stage, I ask them to get their whiteboards out, the little mini whiteboards, and I want them to go back to back, because they are going to draw what this particular lock and key looks like, okay? They could write that down if they want to, but I don't want them to do that yet. I want them to think, okay, first. So we do the back-to-back exercise, and the back-to-back is great, because if you've got really complex diagrams, which this isn't really, but it's a start, you get them to sit back-to-back, and they've got to, one person, I'll explain in a minute, one person is facing the whiteboard, and the other one's got their back to the whiteboard, okay, and the person who is not facing the whiteboard has a mini whiteboard in their hands, and they are going to draw what the person is telling them to draw, okay? They can't see what's up here. And it's a really good little exercise. I've put this here, and the students wouldn't see this, but I've put this here for you guys. And this is in a really nice book. It's called the Teacher Toolkit. And it's a great resource, and I've got that at the end of the presentation, so you can actually look that up and, order it through Amazon if you like. So they would do that. That would take about 5 to 8 minutes. And as soon as they've done that particular exercise, you get them to have a look and to see what they've missed out on, what they haven't drawn, all that sort of stuff. And then they've got to get that into their books. So it's made an impact. You want to have it made an impact. Now, here, with factors affecting enzyme activity, I've got this information here, But this is what I want them to know, okay? But they won't know that. So I get them to think about, brainstorm it, and write down what sort of factors could affect, okay, enzyme activity. So they may not know. Again, they may not know. But you've got to be supportive, and you've got to make sure it's a really safe and secure learning environment. They've got to feel confident in making mistakes and taking risks. So you give them a chance to sort of put some information down. And then after that, you show them this and you say, right, how many of you guys got that? Tick it off, highlight it, get a second colour pen and write down, say, 2 things from here that you didn't know of, okay? And so one thing now, students learn by being active, okay? And too many students are passive. They sit there and they just want to have the information come to them. So a role play is a really good way of getting them to think about how a substrate fits into and acts with a particular enzyme. And it's generally better if you've got 5 students because they've got to think about the substrate concentration. Okay, so if we go back to these things here, they've got to think about the amount of substrate. They've got to think, you could say to them, right, you are in an acidic environment. You are an enzyme and a substrate in a pH 3 of a stomach. Okay, how does how does a protease, okay, act within the stomach? What are the substrates going to be? And then they'll start thinking about, oh yeah, that'll be a protein. Yep, okay, we can do that. And so then they've got to show how many of them are going to be substrates, how many of them are going to be enzymes in that particular stomach environment. And they can role play it and they can act it out. It will be really tricky. And this takes quite a while. To do this properly takes about 15 to 20 minutes. It takes them about 5 minutes to get over their embarrassment, and takes about 10 minutes for them to actually work it out. And then what you will do is you get certain groups, okay, who feel a bit more confident or not so confident, and you get them to role play in front of the class. And then the class gives them constructive feedback, as well as me asking them lots of questions, you know. What was the effect of temperature on your enzyme? You know, what was the pH, you know, effect on your particular enzyme? Why have you only got 2 substrates and not 4? You know, ask them lots of different questions which could be closed, but you can also ask some questions that could be opened, you know, getting them to think about what could inhibit your enzyme activity in the stomach. That's an open question. They don't know. And then they have to suggest answers, okay? So role play, it's really good. It's awkward, but it's a really good way of getting a lot of learning to be made intuitive and easier for them to access later on when they are doing some work or some exercises. Now, even though we've got all our enzymes there, okay, factors affecting enzymes, we do have to get them to think about optimums. Well, with optimums, that is related to temperatures and pH values. Now, they probably won't be able to understand that actually in the role play, because that's quite a general sort of outlook. But if you start giving them a graph like this, they then have to start working out, well, what's happening on that graph? Now, this is for temperature, and this is enzyme activity in a particular type of pH. Now, you could photocopy this page and you give each student a page like this. This is what I would be doing. And I've got the questions on there that they've got to answer, okay, here and here. I've got a challenge on there for my more able students. So they've got something there. They may be able to do this really quickly and work out where the optimum temperatures are, okay? And then also what... then they've got to describe what happens to the enzyme activity going, up to the optimum, and then what happens to the enzyme activity after that. And then you will start to hear students using words like denatured, less collisions, okay, that there's going to be, for example, here in this particular situation, you've got a difference in different types of enzymes. Now, why are there different enzymes? Where are those enzymes? What's the situations? Now, this one's heat tolerant, okay, but and this one here is different places within the body, okay. So this is alkaline situation, so that's the small intestine enzymes, and this is the stomach enzymes. So they start to think about how to link that all up. Now, again, like I said, substrates. Now, you might want to give this to your students, your more able students, or your less able students, so that they can then annotate the diagram in even more detail. Active site, okay, key terminology. Induced fit. Now, I've put that in there because really good students who are academically able would be able to understand that actually enzyme activity is not lock and key. It is the induced fit because the enzyme actually changes shape, okay, when a substrate fits it. And then when the substrate leaves, it goes back to its original shape. So some students will actually be able to understand that. So you might want to give them this extra information so then they can annotate their diagram in even more detail. When they've done that, and you've given them, say, 5 to 10 minutes, and in fact, I don't know why I said 5, it really should be 10, so that they can apply their new knowledge, okay? And then you can show them this graph. And then they can compare this graph, okay, this slide here, to what they've got written down. Now, there's a couple of ways you can do this. You can either just let them do the self-assessment for themselves, or you can get them to exchange their work with another set of students' work, and then get them in a different colour pen annotate that other piece of work so that they are thinking and critically analysing, okay, someone else's work and finding out where the knowledge gaps are. Okay. Now, activation energy, that's something for the more able students. They should be able to think about how to apply that here in this particular graph. Okay, and it's difficult to see that. They may actually have to draw another graph to show what the activation energy is going to look like. So again, you have to think on your feet. You have to respond to what your students are needing at that particular stage and what their interests are in that subject. Okay, so again, more information. You could give that to your students, okay? But the less able students, they're not going to be able to handle that. But your more able students, yes, they definitely can. It's quite complex, isn't it? Like I said. So now we're getting towards the end of the lesson. All that before that I showed you with the role play and with the graphing, all of that was new knowledge. That was practicing and applying the new knowledge. Now we're at the plenary. We're at the final part. And here, even though they started off with, say, 1 or 2 or maybe 3 different bits of information that they added at the beginning of the lesson, it's really important that they go back to where they started, that they can see how much of a knowledge distance they have travelled, and they can put back in there bits, at least three bits of information that they have learned as a result of that lesson and all that information that they have covered. And using a different colour pen is fine. Some students do, some students don't. But as soon as they've done that, a thing that I like to do, okay, so that I can access, you know, like getting them to think about how they've learned, which is metacognition, I like them to write a reflective statement underneath saying, you know, something along the lines of, I must remember that enzymes actually, and they could write anything, enzymes actually are proteins, or enzymes are actually biological catalysts and proteins, and they have an active site on them. You don't tell them what to write, you've got to encourage them to think about what they actually understand. You may actually want them to write down, you know, highlight here things that they find difficult to understand. So they are deciding their knowledge, okay. And I've put at the end of this particular presentation, I've listed a couple of quiz questions, okay, for you to think about when you are interacting with the CIE Biology 610 specification. And getting you to think about the assessments, getting you to think about learning outcomes, because learning objectives are easy, it's already in the specification. But working out what you want your students to understand with the outcomes, that is difficult, okay? It could be designing, it could be explaining, it could be listing, okay? But you've got to be more sophisticated than just listing and stating. And also design a lesson plan. Well, actually do that after you've tried to get a starter going, okay? If you're interested in something, and I've picked eutrophication because that's always a complex topic, but it's a really interesting one visually because you've got green lakes versus clean blue lakes. You could have eutrophication on, you know, like peninsulas. It can be really stimulating visually, okay? And most students don't even know what that is. So you can make a real impact straight away. And then design a lesson plan. Think about parts of a cell and taking students to the stage where they can identify and compare plant and animal cells. That's a nice, easy sort of introduction to lesson planning. Okay, give it a go. It's not too difficult, but give it a go. And then these are my top 5. Each teacher, and you'll find yourselves, you'll end up with your favourites, okay, your sources that you want to go by. Of course, that's what we use for our specification, but here, that's our textbook that we use at Nlcs. And then here, this is the teacher's toolkit book. I really suggest that all teachers look at the different types of teaching strategies there. And these are our practical sites that we go to often, okay? And it's got such a good array of practicals, teachers, lab technicians, some videos and other resources in there, okay? And this is what it looks like. Should you go on and search on the website. Thank you. I hope you have a really good time looking these up and enjoy going through and testing yourself out with designing lesson plans and really enjoy the subject. You enjoy it, your students will absolutely love you for it. Thank you.